So this is number 2 on worksheet 9, and we are trying to prove theorem 6.2. I picked the symbol just because that's what they used in the book. It's definitely not theta, but I'm going to call it theta because I do not remember all of my Greek alphabet. So we are trying to prove that theta, which is mapping G to G prime, is an isomorphism. So the first thing we need to prove is that theta E is the identity of G prime. So we're going to let E be the identity in G and E prime be the identity in G prime. So since E is equal to E times E, we have that theta E equals theta of E times E, which equals theta E times theta E. Also, since theta E is an element of G prime, we have that theta E equals E prime theta E. So therefore, E is equal to theta E. Next, we have to prove that for all n elements of Z, theta of a to the n is equal to theta a to the nth power. So if n is negative, that means that negative n is positive, and we have E equals theta E, which is equal to theta of G to the n, G to the negative n, which is equal to theta of G to the n times theta G to the negative n, which is equal to theta of G to the n times theta G to the negative n power. And then if we multiply by theta G to the n on the right-hand side, this implies that theta G to the n is equal to theta of G to the n. Then, if n equals 0, so we just did a case where n is negative. Now we're doing a case where n equals 0. So if n equals 0, we have theta of a to the n is equal to theta a to the nth power by 2a. That's what we did up here. And if n is positive, then we have theta a to the n equals theta a to the nth power by the definition of an isomorphism. So that brings us to part C. And again, I am terrible at notation, but A with those little brackets over it, that's denoting the set A to the n, such that n is an element of Z. I don't know exactly how to read that, so I'm just going to call it A. So we are trying to prove that G equals A if and only if G prime equals theta A. So because that's an if and only if, we have to prove that in both directions. So to prove it in the first direction, let G equal A. Then by closure, we have that theta A is a subset of G prime. And then, since theta is onto, for any B element of G prime, there exists an A to the K element of G such that theta of A to the K equals B. Therefore, B equals theta A being raised to the K power, and B is an element of theta A. Thus, that proves what we wanted in the first direction. Then we want to prove it the other way around. So this time we're going to let G prime equal theta A. So we know that A is a subset of G. So for any B element of G, we have that theta B is an element of theta A. So for K is an element, any K that's in Z, we have that theta B equals theta A to the K, which equals theta of A to the K. Then, since theta is 1 to 1, B equals A to the K, and theta A equals G. and that proves what we wanted in the left. And that's it. So thank you for bearing with my terrible ability at speaking notation, but hopefully, at least with what's written, it's clear.